Okay, so we're done with activity 2, but we will use this chart in the share and show. So just for the ease of viewing, I'm going to kind of fold my paper down a little bit since I'm not using the book version. So it says, number 1, use the table to write the products, the answers for the row for 2. Now row is this way, so the row for 2 is this row. So we're writing those products, right? 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Are you seeing what's happening? Take a look. If I did 20, I would actually put 20 down here. 22, 24, 26, 28. I wouldn't continue writing there because take a look at that ones digit. The ones digit is repeating, right? You can see that. So when you describe the pattern you see, you would describe that the tens digit increases after the ones digit grows by 2 each time. 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, and so on. So that is how that pattern grows, right? Now, we're going to think a bit about odd and even numbers, even and odd numbers when we're looking at our products. So 5 times 8, 5 times 8 is 40. And we have to know if it's odd or even. 0 is like a 10, right? So this is even. If I need 6 times 3, I'm going to look. 6 times 3 is 18. So 6 times 3 is 18. Anyone that has a 2, 4, 6, 8, or 0 in the ones digit will be even. So 18 is even because 8 is even. Now 3 times 5. 3 times 5. 15. 5 is not a 2, 4, 6, 8, or 0. So this one is odd. And 4 times 4. So here we go. 4 times 4 is 16. 16. We've got a 6. It's even. All right. This is the end of, sorry, I didn't tell you. This was page 166. And we're going to continue on to page 167. Now, use the multiplication table to describe the pattern you see. I'm going to bring back this multiplication table here. In the column for 10. In this column, what do you see? What's happening in the ones digit? What's happening in the tens digit? So in the column for 10, the ones digit is always 0, right? But in the tens digit, it's increasing by 1. The tens digit is, I'm just going to put increasing, use that up arrow, by 1. I'll make it look like a 1 and not just a line. Now for number 7, take a look for the column, in the column for 8s. This one right here. What do you notice that's happening? Take a look. Look at the ones digits. Look at the tens digits. So the 1 is going 0, 8, 6, 4, 2, 0, 8, 6, 4, 2. That is the pattern. I'm just going to simplify this. The ones pattern is 0, 8, 6, 4, 2, 0. And these are all even, right? Just like when we did the 2s. So those are all even. And in the tens digit, it's nothing, nothing, 1, 2, 3. 1, 2, 3, 4, 4, 5, 6, 7, 8. And this would be 88, so 8. So in the tens, pattern is 1, 2, 3, 1, 2, 3, 4, 4, 5, 6, 7, 8, 8. If it's a multiple of 4 or 8, it looks like, I wonder if that would continue if we went on. I know 8 times 11, I know is 88, so it would give us that pattern of 0, 8. 6, 4, 2, 0, 8, 6, 4, 2, 0, 8 would continue in the ones, and this would double in the, it would be an 8 again in the tens place. All right, now we have to write odd or even. I want you to use your chart to help you with the multiplication if you're not sure. All right, and I'm going to have you give this a go. 4 times 8, 32, and even. 5 times 5, 25. 5 is not a 2, 4, 6, or 8, so it's odd. 7 times 4, 7 times 4, 28. It's a 2, 4, 6, or 8. Yep, it's an 8, so it's even. And then 2 times 9, 2 times 9, go across, go down, 18. The 8s are even, right, in the ones digit. It doesn't matter that the tens digit is a 1 and the tens digit is a 2 here. It's really only the ones digit that tells you if it's odd or even. All right, we're going to go a little deeper, use the multiplication table, and then rewrite the pattern correctly. Is it 6, 12, 18, 22, 30, 36? If we're counting by sixes, let me move this, fold this down a little bit. We're counting by sixes. 6, 12, 18, it's not 22, it's 24. So 6, 12, 18. 6, 12, 18, 24. Oh yeah, it goes like this. 6, 12, 18, 24, 30, 36. And the spider said 42, 48, 54, 60, 42, 48, 54, 60, 66, 72. How do you do? All right. Now we are going to fill in this chart. We're going to complete the table and describe the pattern that we see in the products. So 5 times 2 is 10. 5 times 2 twice, right? A 4 is just doubling the 2. So that's 20. 5 times 6 is 30. Really what I'm doing, if I'm adding 2, 4, 6, 8, I'm adding 10 each time. So 5 times 8 is 10 more than 5 times 6. 40. 5 times 10 is 50. So the product increases by 10. Okay? When multiplying by the 2's. So I'm multiplying by 2, 4, 6, 8, right? Which are even. I'm going to use the number sign, numbers. When I'm multiplying here, 1, 3, 5, 7, 9, these numbers up here, these are all odd, right? So let's see what happens. 5 times 1 is 5. 5 times 3, 5, 10, 15. 5 times 5 is 5, 10, 15, 20, 25. You see what's happening? I'm increasing 10 more. So 5 plus 10 more is 15, plus 10 more is 25. And I'm adding 2 groups of 5 each time. So between 5 and 7, that's 2 more groups of 5, which is a total of 10. 5, 10, so 25, 30, 35. 5 times 9 is 45. So it still increases by 10. When multiplying by odd numbers, but the ones digit, I want you to take a look at that ones digit. When you're multiplying by even numbers, the one digit is staying a 0 because these are even numbers. But these odd numbers, when you're multiplying by the odd numbers, these odd numbers give you an odd number, give you a 5 in the ones digit. So notice that. Okay, now let's see. Explain how patterns of the ones digits in the products relate to the factors in exercises 13 and 14. So if this factor is even, the product is even, right? If this factor is odd, the product is odd. So if the factor is even, then the product is even. But if the factor is odd, then the product is odd. Okay, so that's working for the 5s that way. Now, number 16. We've got Helene selected an odd number to multiply by the factors in this table. Write even or odd to describe each product. So this is an odd number, just like 5. So let's pretend it's 7 and see what that does. 7 times 1 is 7. 7 times 2 is doubling 7 is 14. 7 times 3, 7, 14, 21. 28, 35, 42. So this is, if I were filling in these products down here, right? 7 times 1 is 7. 7 times 2 is 14. But let's take a look. 7 is odd. 14, you've got your 4 there, is even. 21, 1 is odd. 28, you've got an 8. 8 is even. So an odd number times an odd number gets you an odd number. An odd number times 2, which is 2 is even, gives you an even number. An odd number times an odd number, 3 is odd, gives you an odd number. An odd number times an even number times 4, 4 is even, gives you an even number. 35, is 35 odd or even? So odd number times odd number, 5 is odd, so the product, the answer, is also odd. Okay, so this is a pattern that will continue. Mathematicians look at patterns and see how we can kind of make rules with the patterns. Now, number 17, here on page 168. This is a lot of mathematical practice, mathematical thinking. If this is making sense to you, please continue on. If you feel your brain is full, you may stop the video here. So math arguments. Whose statement makes sense? Whose statement is nonsense? Explain your reasoning. So this boy is saying the product of an odd number and an even number is even. Okay? And think back to what we just did. He's saying an odd number times an even number, like 2, like 7 times 2, is even. Okay, and she, this little girl, is saying, they have names, Gunter and Giselle. So Giselle is saying the product of 2 even numbers is even. We didn't try out 2 even numbers, did we? So let's see. Let's see what they say. We kind of already practiced Gunter's idea, right? We think he is probably right. That's what we found, is that an odd number times an even number will be even, right? Odd times even is even. So if we look at his work, 3 times 4, 3 is odd, 1, 2, 3 in this column, times, I'm sorry, yeah, 3 in the column, and there's 4 columns of 3. This is kind of backwards for that picture, I think. Gives you even, gives you 12. So I can circle 2 equal groups of 6 with no tiles left over, so the product is even, right? You can make 2 equal groups, none left over, it's even. So if you've got an even number here, 2, times an even number here, 6, 2, 4, 6, 8, 10, 12 gives you 12, and this is even. I can circle 6 pairs with no tiles left over, so the product is even. So whose statement makes sense and whose statement is nonsense? The product of an